Hello, my name is Bob Kulver. I'm the new staff scientist one at the Hexagon Lavish. Um, I'll start off a little bit first with my background. I've come to THL via the universities of Minnesota, Nebraska, and Chicago. My background in my scientific days was in theoretical chemistry and physics. I did mostly computer simulation, modeling, and numerical work, which involved the thermodynamic properties of solids, liquids, and gases, as determined not so much by simulation, but by the evaluation of the phase integral or the partition function, which will yield a free energy, which is a very important result in phase equilibria that you cannot get through simple internal energy, as you would do from a thermodynamic integration or by molecular dynamics or standard metropolis method, Monte Carlo. Enough about that. I went from the theoretical chemistry into solid state physics and material science. I did more work in computation, especially on supercomputers and array processors. I worked on ways of speeding up molecular dynamics calculations, in particular of ionic solids, those comprised of long-range forces, which are typically quite the devil to deal with when you're doing any kind of a simulation where you need periodic boundary conditions. So my background in chemistry, material science, and physics covered a lot of ground in the computational areas of eigenvalue, eigenvector problems, optimization, and eigenvector, let's say, visualization of eigenvectors when looking at dynamics of solids. Also, working on the modeling of ionic liquids, solids, and gases also turned out to be through the help of a special Fourier transform function, a way to calculate or do simulations of free energy of plasmas of great interest to the physics and astrophysics community. More recently, I've been working with Fujitsu America in Pittsburgh. They had a project that was devised at Carnegie Mellon University back in the 90s. It was a graphic simulation package that worked using genetic algorithms and multi-objective optimization. Uh, they had some dubious results and they had some trouble with the clients, so I was working on the multi-objective part of this optimization, which is a function of countless, let's say, 100 variables, and we would like to see which of these variables are the so-called heavy hitters in determining the performance and the performance metrics of this optimization method. So that is what I was working on most recently. I went over what I did in the past in the sciences, and now at the Hexagon Lavish, I will be mainly working on the PIR project, which is Premier Information Retrieval. That in itself will use a lot of ideas and notions of big data analytics. Quantum mechanical superposition is going to be a major part in determining the validity of the PIR. And also, I'll be working a little bit on the Gaussian mixed models, which is a way of modeling complex behavior with a sum of Gaussians, not too different from the way you would do it in a quantum mechanical simulation where you have a basis set of wave functions and you solve the Schrodinger equation to determine the coefficients thereof. So there it is. In a nutshell, I'm looking forward to starting to work at the Hexagon and have a good day. Thank you.